Okay, so many moons ago, I left off promising to do a tutorial on data analysis, and I'm eventually going to show how to do that in Python and in MATLAB slash Octave, or Octave is the open source equivalent of MATLAB. But I thought I'd start out just showing how to do it in Microsoft Excel, because Excel is very easy to use. It's available on most it or some equivalent of it is available on most computers, or you can always use Google Spreadsheets to do the same thing. So this is the data from the lecture I left off with, where, or sorry, from a lecture prior to that, lecture number 3, where I was showing some measurements of time and distance and the speedometer, which it's actually just, where is it? It's, yeah, this video file here, where you can see I'm videotaping speedometer and the odometer with the timer, and I'm driving along here. So you see, stop it at various points, read the odometer up here, speedometer here, and this timer up here, and then type those values into Microsoft Excel. So now, how do we do some basic analysis on this? Well, all we want to do is graph this, right? So let's say we want to do something fairly straightforward, which is to do some trickery first, because, well, actually, let me just graph it the naive way and I'll explain the problem. So, see, time in seconds, distance in miles, and then speedometer reading in miles per hour. But there's a mismatch, right, between seconds here and miles per hour here. So, but all we need to do is select this data by just clicking and dragging. Boop, that. And then do insert, and then go to charts and select scatter. So you want to make sure to select, the correct type of scatter plot, which is this kind where it just has the dots. So you see, this has the speedometer and odometer readings both as a function of time, and you see they're off. So now let's just select those two columns, and we get a nice straight line. So now let's say we want to analyze this a bit further, and we say, okay, we have some data in approximately a straight line. Why don't we ask Excel to just add a trend line for us? So you click on the data, so you click on cell. So you can click on the chart, the graph, click, and then the data. So make sure you actually click on a data point, and they'll all be highlighted like that. And then right-click, add trend line, and we want to make sure to display equation and display r squared, and that way we'll be able to see the values. But you'll see the values are kind of useless, right? What is that? 0.009x, right? So 0.009 would be our speed, right? Because it's a pretty simple equation where distance in miles per hour is distance in miles over time in hours, but our time isn't being measured in hours, it's being measured in seconds, so we need to divide our time by 60 twice, so 60 times 60 is 3600. So let's do that real quick. And let's get another column, let's call it time in hours. And so click on this cell here and put it equal to, and then click on the time cell over here, and then we'll do divided by 60 divided by 60, so that we get seconds, or sorry, so that we get hours instead of seconds. And then let's click and drag, because remember in Excel when you click and drag, you do the corresponding operation in the cell that's adjacent in the direction you're dragging. So it'll turn this column, it'll do the same operation for this whole column down corresponding to this whole column down. And so then now let's just delete that chart. So now let's do select this, and then control click and select all of this, and then do insert again, charts, scatter, same routine as last time, add trend line, display equation, display R. Oh wait, oh sorry. So that's another peculiarity of Microsoft Excel, is that it always views the column to the left as the independent variable. So let's delete that chart and do that again. So we have to copy and paste this. This is why Excel is clunky, and I'm going to be doing a tutorial on Python in short order, but I wanted to get back on top of doing things. So please bear with me. So now we have the independent variable on the left and the dependent variable on the right, because Excel is kind of brain dead and doesn't know how to handle anything else. Okay, click on the data, add trend line, and now it will, instead of being transposed, will be correct. Okay, there we go. That's what we wanted. See, x equals 30, y equals 34.5x, so 35 miles an hour, which actually makes sense, because let's use another Excel function here, which is the average caps lock right next to the button there. Okay, and the average of the speedometer is 33, so not so far off, right? So that's good. The average speed we get from looking at it at this approximate straight line going through the distance versus time is equal to the average of all the speedometer readings. So, you know, yay, some basic reasoning about physics actually does work. Let's get a little bit more sophisticated here, and let's do distance differences. And what we're going to do here is we're going to say we want this equal to the distance here minus the distance here, and those are all just going to be 0.1. Spoiler. And then this gets us invalid because there's no value above that. Okay, now let's do time differences. Let's do the same thing, but with the timestamps, and we'll do it for hours. It's equal to this minus this. That, all right. And now let's add another column where we do distance divided by time, where we do this set, where we do equal to, and then click this divided by this, and that will give us the speed in the interval where it was going. So now let's sort of put this all together, where let's take the timestamp in seconds, and we'll select the speedometer reading, and we'll select distances divided by times. And we'll do insert charts line. Oh, sorry. Let me do that slightly different version. So this is a good chance to talk about how you can either do scatter plot with a connecting line or without. So we'll do this scatter plot with a connecting line, and you'll see those don't perfectly line up, but it is, once again, the speedometer reading, which is what's being shown in blue, loosely lines up with the average speed by looking at the distance divided by the time difference, which is what's being shown in orange. So that's not a very good Excel tutorial, but Excel is very clunky, It's, you know, relatively easy to use, but it's not particularly efficient, and it's kind of hard to do things. So I'll also do another tutorial on Python and a third one on Octave using this same data set. So, yeah. Bye.